Today in today's tutorial, we're going to talk about how to find limits and what limits are. All right. Well, first off, what is a limit? Well, a limit, if you go to tutorials for calculus phobia, which is located at calculushelp.com, there they talk about a limit being the intended height of a function. All right. Now, the intended height of a function, well, there are two key words that we need to focus on. Intended means what you think or what it looks like it's approaching, and height meaning the outputs or the y values of the function, or the fx values. So what we're looking for is we're trying to figure out where does this function look like it's approaching? Where does its outputs look like it's approaching? So as we plug in different values, we will get you're approaching a different number. So, for example, if I have a function, I'll draw a nice big function right here, and we want to identify where this function approaches. So we're going to take a point somewhere, and we're going to say, okay, this point, we want to be approaching C. And we'll say this point C. And obviously this other point is going to be f of c. Now for a limit, we're looking for where is this intended height going to be? Well, when we see this intended height, in order to get there, we can observe, well, all right, just by looking at the graph, that as we approach C, right, from either side, the right or left, we start inputting some values. Now the values we input that they call that actually delta. So what we can do is we can take C and we can input like a delta, which is a very small number, okay? And over here we can take C, we can subtract delta, which is another very small number. But as we get closer and closer, and delta gets smaller and smaller, once again this is delta. All right, very small value, okay? And when you take this very small value, and that value can change, what happens as we get closer and closer to C? But we actually don't want to plug in C. Now what happens when we plug in values, you realize that we start getting some different output values. So as I get closer to C, I get right here, we see that there is a value that is associated with it. Okay? Or we get an f of c. We get closer to f of c. So as I get right here, we get closer to this f of c value. Well, this f of c value, if I can draw this, if I can, right here, we get another one that's going to be like right there. We notice that, all right, our outputs, all right, our intended height appear to be approaching this f of c. All right, and this value right here can be f of c, and it was going to be a little bit more than that, so it would be plus epsilon. Epsilon is this larger value, and then right here what we have is f of c minus epsilon. So as we start plugging in these values, we notice that we are approaching this value, this number, all right, which is the intended height, which appears to be f of c itself. But this is where we come up with our limit expression. To write this out, we say that if we want to approach a value, we need to plug in some values that are closer to c. So we say we're going to take a limit as x approaches c. This is x approaches c of a function that we have. So in this case, we're using f of x, all right, f of x. And so we're taking the limit as x approaches c of fx, or limit of fx as x approaches c, all right? And what is that value going to equal? Well, that value appears to equal, well, it will equal a limit, because we're approaching a limit from both sides. So what does that limit equal? Well, in this case, you can see that this limit equals, it appears to equal f of c itself. Now, that doesn't always happen that way, but in this case, all right, it would be. All right, but this is our limit expression. All right, in order to find a limit, we find the intended height of a function. How do we do that? Well, we start plugging in values, or start approaching c, our inputs from either side. So plug in a delta, which is a really small number. So if I get a concrete value, let's say this was 4, all right, and delta was like 0.0001. So we take like, plug into our little table, all right, x and then our f of x. We'd have 4.0001, what that value is. And that value can change, get really, really close, okay, arbitrarily close, as they say. And what we have then is we get out an output, which would be f of 4.0001, okay, and that would be some value, all right, that would just be past f of c, or f of 4, okay, and we plug in another value, which would be just less than that, so it would be 3.999, oops, ran out of room, 9, and what we have is an f of 3.9999, and we have our values. That value, if they happen to approach the same way, that's our L. That's our intended height. Okay? So a limit is intended height of a function that we approach two different things. All right? And here are some different explanations that we can say from here. The height that a function f of x intends to reach L as x approaches c from either side. In a lot of books, they say let f c and L be real numbers. Function f has a limit L as x approaches c if, given any position number epsilon, there's a positive number delta right here, such that all x, the distance between them, is between those two values. You can write it like so. Or the informal definition, which you see in a lot of different places, is that fx becomes arbitrarily close, fx being the output, becomes arbitrarily close to a unique number L as x approaches c from either side. Okay, the limit f of x as x approaches c is L. Okay, well, let's look at some examples that would maybe help us figure this out. All right, when we find limits, we can find the limit graphically, all right, and compare the height L as x approaches 0 from either side. So look at this, let's find our intended height. So when we have this, between the limit as f of x approaches, limit of f of x as it approaches 0, and notice that there is a plus sign here. That plus sign means we are approaching x, or plugging in values to the right. All right, to the right of x. Okay, the right of x. So over here, we look at 0, and the value that we could plug in. If we look at this, here's 0. All right, and I could plug in a value like 1. But we have to get a little closer because that's the right of that, and we can see as we get closer and closer, all right, we notice that our values appear to be approaching. So what's the height? Appears to be approaching 0. 0 itself, because our value is 0 at 0. So to the right, we would say our limit is approaching 0. So the limit as x approaches 0 to the right of x appears to be approaching that value, which is 0. We also do that to the left. And as we approach this to the left, when you see a little minus sign next to a limit, that refers to left of x. So we're looking for, what is the value to the left of x? Well, what's our intended height? Well, the limit as x approaches 0 to the left of x, well, appears that it is approaching the same value, because we can plug in 1, and that value is a little smaller. And as we get closer, it also appears to be approaching 0. 0. Well, the right and left side both approach the same values. So, because of that, going back to our previous definition, we know this informal definition, this is known as the informal definition, we know that f of x becomes arbitrarily close to a unique number L, that's our limit, as x approaches c from either side. So that means from both sides, from the right and from the left side. Well, because we're approaching the same value, 0 and 0, from either side, that means our intended height appears to be 0. But that's our limit. That's our limit. So in other words, we can write this. Ultimate formal definition. If a limit as x approaches 0 from the right of x equals a limit as x approaches 0 from the left, right, so this is the right, and this is from the left. If they equal the same value, all right, which is L, then the limit as x approaches 0 of x equals L. Okay, and obviously we can plug in c in there. It doesn't have to be 0, whatever that would be, that would equal L. So that is an introduction of what a limit is and how it works. Hopefully that made sense. If you have any questions, you can always contact me. Good luck. And God bless.